Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Tabo Mboweni. This lesson is brought to you by the Free State Department of Education in collaboration with Pakama Research and Development. You can interact with us on the WhatsApp number 079 578 2908. Today's lesson is on the exam preparation for paper 1 that you are about to write tomorrow. Let's get started. Now, your examination will be divided into two sections, that is section A and section B. Your section A will be the multiple choice questions, which will cover the entire syllabus with a total of 20 marks. Then we have the section B, that is the long questions, that is going to cover 130 marks. The duration of your examination is going to be 3 hours, which is equivalent to 180 minutes. Now, if you can work out the 180 minutes with the 150 marks in total, you will note that each mark is allocated only 1.2 minutes to work on. Now, let's look at the content that will be covered in the exam as you're going to write tomorrow. Now, we see the content in mechanics, which is allocated 63 marks. That is the most of the marks, or the bulk of the marks that is allocated there. And under mechanics, we have Newton's laws of motion, we have projectile motion, momentum, and work energy and power. So when you prepare for your examination, bear in mind that this mechanics is allocated most of the marks, and more time should therefore be given to those sections. Then we have wave, sound, and light, which is allocated only 17 marks, plus minus 17 marks. And under wave, sound, and light, we have the Doppler effect. So the Doppler effect will be allocated plus minus 17 marks. Then we go to the next part of the content, that is electricity and magnetism, which is allocated 55 marks. So that is the second part of the content that is allocated most of the marks. And under electricity and magnetism, we have the electrostatics, we have the electrodynamics, and we have the current electricity. So when you prepare, just bear in mind that those sections under electricity and magnetism are carrying the bulk of the marks. Then lastly, we have matter and materials. Under matter and materials, we have the photoelectric effect, which is allocated only 15 marks. So prepare wisely by looking at the marks that are allocated for each and every section as you're going to write tomorrow. Now, let's look at what is it that you can easily get as you write your examination. We are looking at the quick wins. Those are the marks that you can easily get as you write your examination. We want to refer you to the Examination Guideline 2021. While preparing for examination, it is very wise to refer to the Examination Guideline 2021 that is going to tell you exactly how your examination is going to look like. Now, the section B, which is the long questions, will require you to remember a definition or two in each question. Therefore, it is very important to know all your definitions before you go to your examination. Now, when you are doing your multiple choice and all the long questions, it is very, very important to refer to the data sheet. While referring to the data sheet, make sure that all formulas are written exactly as they appear on the data sheet before they are being manipulated. So all the formulas are going to be copied from the datasheet as they are, then they will be manipulated later on. Now, when it comes to definitions that are accepted are coming from the examination guideline. If a definition is not as per examination guideline, it's not going to be accepted. Definitions should really appear as they are on the examination guideline with all the keywords that are important in the examination guideline. There will be 0 or 2 marks awarded for all the definitions as they appear on the examination guideline. No partial marks will be awarded for the definitions. It's all or nothing. Now, when answering the multiple choice questions, we advise that you do not leave any question unanswered. All the questions on the multiple choice, including the long questions, should be answered. Do not leave any blank spaces when you are answering your question paper tomorrow. Now, let's make sure that we look at all the keywords and ensure that we read carefully and make sure that we understand all the questions before we answer. We need to make sure that everything, all the questions make sense before we attempt to answer. So let's pay attention to all the keywords and make sure that we fully understand the questions before we answer. Now, there is grade 10 content that will be examined in the paper that you're going to write tomorrow. The grade 10 content, grade 11 content, together with grade 12 content will be examined tomorrow. Let's have a look at what is it that will be in your exam tomorrow that is coming from grade 10. We have firstly here, the principle of quantization of charge. This principle was learned in grade 10 and it will also appear in your examination tomorrow as you're going to write. There is a formula that is associated with that you see on the data sheet, N is equals to Q over E. So this formula is related to this principle of quantization of charge, which states that every charge in the universe is an integer multiple of the charge of one electron. Every charge in the universe is an integer multiple of the charge of one electron. You will also see that this E is the charge of one electron, which will be provided to you on the data sheet as 1,6 times 10 to the power negative 19 coulombs. The value will be provided on the data sheet as negative 1,6 times 10 to the power negative 19 coulombs. Now, we also have the law of conservation of charge that was learned in grade 10 that will be examined in your grade 12, which says that charge can neither be created nor destroyed. So the total charge in any physical process should remain constant. Therefore, it will be wise to revise this law as well. Now, the words uniform velocity and uniform acceleration will be very, very important as you go to your examination, and it will be very, very important for you to understand these words: uniform velocity, uniform acceleration. They may also come as constant velocity and constant acceleration. So it is very, very important to know how these words are applicable. The principle of conservation of mechanical energy. This principle, you see that in grade 10, this formula was provided in the data sheet on the examination. It is important now to note that in your grade 12 paper, the data sheet will not provide this formula that was provided in grade 10. So it is important that you remember the formula for the principle of conservation of mechanical energy by heart. You should know this formula as it will not be provided on the data sheet. The principle, however, states that the total mechanical energy of an isolated system remains conserved or is conserved. The total mechanical energy in an isolated system is conserved. Refer to the examination guideline for all these definitions. The grade 10 work, we look at the data sheet. We have seen the principle of quantization, the principle of quantization of charge. And then we also have the second formula here. This formula will be used in electrostatics. And this is the second formula that will not be provided on the data sheet. This formula that is used when the two charges are touching and then they separate, the formula will not be provided in your examination. Therefore, it is important that you know this formula by heart. You learn the formula, you must be able to memorize the formula and remember it when you write your examination. Now, we have talked about the principle of quantization of charge. We have seen that it relates to the formula as indicated. The law of conservation of charge, we have indicated that you need to revise that. The keywords uniform velocity, uniform acceleration are very important. We have indicated that. The principle of conservation of mechanical energy, we have indicated that. And then your knowledge of series and parallel circuits from grade 10 will be very, very important to revise as well. Now, we also have this formula, V is equals to frequency multiplied by wavelength, that will be used in your Doppler effect. And that is a formula that was learned in grade 10 through the knowledge of waves, sound, and light. Now, let's carry on to see what is it that you need to remember, which you have learned in grade 11. From your grade 11, which forms part of mechanics, that is Newton's laws, you need to be able to go and revise your Newton first law, your Newton's second law, Newton's third law, and your Newton's law of universal gravitation. You should be able to state these laws, and you should be able to apply these laws in the given situations as they are going to appear on the question paper. Now, from grade 11, we also have electrostatics that needs to be revised fully. And then in your electrostatics, you need to be able to state your Coulomb's law, and you need to be able to define your electric field and define electric field at a point. These definitions are there on your examination guideline 2021. Make sure that you know all these definitions by the end of today. And the electric circuits, still from grade 11 work, we need to go and be able to revise the Ohm's law. It is also there on your examination guideline, the power and the energy. So all these concepts will be in your examination grade 12 as they are studied in grade 11. Now, the multiple choice questions in grade 12, we have already indicated that they are allocated 20 marks. There are 10 of them. Each one of them is allocated 2 marks. Now, when you answer these multiple choice questions, it is very important that you do not only focus on the option that you think is correct. It is important that you think also about the reason why the other 3 options are incorrect. In that way, you will be able to get the most correct answers. In the multiple choice questions, there will always be 2 options that are distractors. It is very important that you start by eliminating the 2 options that are distractors so that you are left with only 2 options that are very close to the correct answer, so that you may be able to choose the most correct answer. Now, we talked about eliminating the distractors. Now, there are key words that you need to pay attention to. Some of them will be written in capital letters. It is very important that you pay attention to these keywords, as they might lead you to the answer. They might lead you to the concept that you need to apply in that particular question. So upon completing your multiple choice question, go through the questions and check if you really answered all the questions correctly. Let's now have a look at how do we really attempt some of these multiple choice questions. Some of these multiple choice questions might require some calculations. Some of them, they might require you to recall some definitions. And it is very important that when you answer your multiple choice questions, your data sheet should be very close by. You need to refer to the data sheet to answer most or some of these multiple choice questions. Let us go through this multiple choice question together. Now, the weight of an object on the surface of the earth is W. We are told the weight of an object on the surface of the earth is W. What will be the weight of the object on the surface of another planet of the same? We see the key weight here in capital letters, in the planet of the same mass as that of the earth, but twice the radius of the earth. So for us to answer this multiple choice question, we need to be able to identify the formula from the data sheet that is applicable in this question. Now, you will see that there is a formula on the data sheet that says F is equals to G M1 M2 over R squared. So this is the formula that comes from the Newton's law of universal gravitation. In this question, we are told that this force will be represented by W. Therefore, we can write this formula as W is equal to G M1 M2 over R squared. Now, this formula now will be applicable now in the first line of our question that says the weight of an object on the surface of the earth is W. So we take it that on the surface of the earth, what is in the brackets represents W. Now let's go to the next planet that we are told about. We are told that in the next planet, the mass is the same, but the radius is double or is twice. So now, how do we work it out? Now, in the second planet, we are going to substitute G as it is. The first mass and the second mass did not change, but the radius was changed. So the radius is 2r now, and we do not forget to square. Remember that this is equal to the W, which is the new one, in the second planet. Now, if we work with this on the calculator, we are going to see that this will work out to G M1 M2, and 2 squared will give us 4r squared. And if we take the 4 out as a factor, we are going to have 1 over 4 into G M1 M2 over R squared. Now we remember from the beginning that we represented the G M1 M2 over R squared as W. So this should work out to 1 over 4 W. Doing that, we can go now to our options that we are given. We're given options A, B, C, and D, and choose the correct answer. We therefore realize that our best answer here is A. So that is how we work out some of these multiple choice questions, by referring to the data sheet, by also referring to the laws and principles that we have learned. Let's go now to the second multiple choice question and see how do we go about choosing the best option. A constant net force acts on an object moving in a straight line. So we see here that we are looking at the constant net force. There is a net force that we need to look at, and this net force we are told that is constant. Which one of the following quantities associated with the object will remain constant We want the other one that should remain constant during the motion. We are told the net force is constant, and the other quantity should also remain constant. Let's have a look at the options that we are given. For kinetic energy, we can associate kinetic energy with a certain formula on the data sheet, that is half mv squared. And then acceleration, we can associate acceleration on the data sheet with the formula F net is equals to ma. And momentum, we can associate momentum with the formula P is equals to mv. And velocity, we can associate it with the 4 equations of motion that are given on the data sheet. Now, we go back to the question and see that we want to look at an option that talks to the constant net force and the other quantity that should also remain constant. Now, if we look at B, there's no way this formula is talking about the net force. We look at D, there's no way that this formula is talking about the net force. A, there's no way that this formula is talking about the net force. We are left with C. What is this formula in C coming from? This formula is coming from Newton's second law of motion. And according to Newton's second law of motion, when a net force acts on an object, the object should accelerate in the direction of the net force, with an acceleration that is directly proportional to the net force and inversely proportional to the mass of the object. So what are we getting? We are getting that acceleration is directly proportional to the net force. So if the net force is constant, we also expect the acceleration to be constant. And therefore, we see option C as the option that best describes the scenario that is described above. That is how we can go about working out some of the multiple choice questions. Now, let's now recap the Newton's laws, as we have indicated that they will be assessed in your examination. That is your question 2. In your question 2, you expect to see the Newton's laws. Now, let's look at the Newton first law. Newton first law. How will you know that now the examiner is asking you to apply Newton first law? When you're applying Newton first law, what you need to remember is that the net force is equal to 0 Newton. How will you know that your net force is equal to 0 Newton? There are certain key weights that you will come across that explains that. The key weights here would be constant velocity. When you hear the word constant velocity, or the object is at rest, the object being at rest or the object moving in a constant velocity implies that the acceleration there is equal to 0 meters per second squared. So if the acceleration is 0 meters per second squared, we know that our net force is equal to mass multiplied by acceleration. So any number multiplied by 0 will be 0. That's why we see here that our net force is supposed to be 0 when we are dealing with our Newton's first law of motion. It is very important to substitute this 0 because this 0 is also allocated mass. Let's look at our Newton's second law of motion. What we need to recall with our Newton's second law of motion is that the net force is not equal to 0. The net force is either greater than 0 or less than 0. The formula for Newton's second law of motion, we have already talked about it. F net is equal to ma, which you also need to be able to state it in weights. And we also have Newton's second law in terms of momentum, which you also need to be able to state in weights. We are going to look at how to deal with those Newton's second law questions as we proceed with our lesson. Then we have Newton's third law of motion. Newton's third law of motion deals with two bodies. In your multiple choice questions, you might expect questions where action, reaction pair of forces will be required or will be tested. It is very, very important that two bodies should be involved. So action, reaction pair of forces cannot be acting on one body. They need to be acting on two bodies. For our Newton's third law of motion, we need to know that when object A exerts a force on object B will simultaneously exert a force on object A, and that force must be of the same magnitude but in the opposite direction. So that is our recap on the Newton's laws of motion as learned in grade 11. Now, the applications of Newton's laws of motion. We need to learn how are they applied, and the following points will be very, very important as we look at how these laws are applied in the question papers. Now, in any question where we need to apply this Newton's laws of motion, it is very, very important to identify all the forces acting on the object. And in doing that, no question can be answered without drawing a free body diagram or the force diagram. And when you're drawing that, it is important also to note that if the examiner asks you to draw the force diagram, use a box. If they ask you to draw a free body diagram, use a dot, and also follow exactly what the examiner is asking. If they're looking for the force diagram, draw the force diagram. If they're asking for the free body diagram, draw the free body diagram. These are the easy marks, and these are the marks which every learner is supposed to get. Now, there are also other important weights that are very important as you apply your Newton's laws, rough surface and smooth surface. If you come across the weight, the rough surface, this indicates that the frictional force is present in the surface, or the surface has frictional force. If you come across the weight smooth surface, this should indicate that there is no friction. So frictional force is not present if the surface is smooth. Now, be careful to the mark allocation. For an example, if you are asked to draw a free body diagram for 5 marks, this should indicate that 5 forces are needed in that free body diagram or force diagram. So the mark allocation is very, very important. Now, there are questions that are involving calculations, and if it is a routine calculation, the mark allocation will be as follows. 1 mark will be for the formula as it appears on the data sheet. The second mark will be for the substitution, and the third mark will be for an answer with units. All answers should have units. All answers should have units, and we also pay attention to vectors. Now, some answers will have units, but if they are vectors, they should also have direction. So only scalar quantities will have an answer with units only. But if it is a vector quantity, we expect an answer with a unit and direction. So for these multi-step questions that are not routine, we expect you to get 4 marks or more. The formula sheet that you're going to receive, we have your Newton's second law of motion formula. We have the formula for calculating the static friction. It is very important that you focus on these subscripts. If the subscript maximum is not included, you might lose a mark for that. We also have the formula for momentum, the formula for kinetic friction, and this is the formula for calculating gravitational force. Most of the learners are used to using FG. On the data sheet, however, is given as W. And then we also have the formula for Newton's second law in terms of momentum. And then we also have a formula for the change in momentum. This is a formula that will be given for Newton's law of universal gravitation. Can you use either one of them? And then we can also have 2 other formulas that are used to calculate the gravitational acceleration of a certain planet. So that is our data sheet. It is very important that all the symbols of all the formulas in the data sheet to be learned and understood, and to also know when to use any particular formula. Now, let us start now and look at one or some of the Newton's laws application and see how do we go about solving these particular questions in preparation of the exam that you are about to write. Let us read together. It is very important that we read and understand the question fully before attempting to answer. A 60 kg box is pushed on a rough, we learn that the surface is rough, horizontal surface with a force F. So we must be able to see that force F acting at an angle of 60 degrees to the vertical axis. We are told that this 60 degrees is to the vertical axis as shown below. Now, I hope we see the diagram and we see everything that is being described there. Everything that is being described in the statement, you should make sure that you really see exactly what is being described. The information continues to say that the box is accelerating at 0.02 meters per second squared. Now, we now learn that we need to apply Newton's second law of motion, because we see that the net force is greater than 0, and then we are told that it's accelerating due east. The ratio of the magnitude of the applied force, this is very important. The ratio of the magnitude of the applied force and the mass of the object is 5:2. Now, this part of the information is very crucial. Now, what is this telling us? We are being told that the applied force to the mass, there's a ratio associated to that. And the ratio is in the order that is given, 5:2. And we know that the mass is given. The mass is given. And if the mass is given, the applied force is not given. But with the ratio, we can learn that we can easily get the applied force because the ratio is given and the mass is given. Now, this ratio can help us to get the applied force. How can we do that? We can easily cross multiply from the ratio and see that 2 multiplied by x will give us 2x, and then 60 multiplied by 5, 60 multiplied by 5, that gives us 300. And then if we divide by 2 both sides, we see that x is equals to 150 newtons. We are able to get our applied force, which is 150 newtons. So we haven't started looking at the questions. We were just looking at the information that is provided. And by looking at that information, we were able to get the applied force. Now, let's start looking at the information that is provided. 2.1, state Newton's second law of motion in weights. Now, in any Newton's laws question, there will always be a law that needs to be stated or a quantity that needs to be defined. In this case, it is Newton's second law. And you should be able to state this law from the definitions provided in the examination guideline 2021 as when a net force acts on the body will accelerate in the direction of the net force with an acceleration that is directly proportional to the net force and inversely proportional to the mass of the object. If this definition is stated as it appears on the examination guideline, the 2 marks should be awarded to you. 2.2, Draw a labeled force. This question says draw a labeled force diagram showing all the forces acting on the box. We also see that 4 marks is allocated there. So with the 4 marks that is allocated, we are able to tell that 4 forces are expected from us. Now, the word force diagram indicates that instead of using a dot, we are going to use a box to represent the object. And we can now start identifying the 4 forces which the examiner is expecting by starting by looking at the first force being the weight. And the weight is starting from the center here of the box, indicating that it's exerted by the earth. Then we have the normal force, which is exerted by the surface, normal force. Then we also have a frictional force also coming from the surface. So that will be our Fk. And then we'll also have the applied force. So the applied force, as we see from the diagram there. So that would be a representation of the 4 forces that the examiner is expecting. Then we go to 2.3. 2.3, the examiner is asking, calculate the magnitude of the. Now, 2.3.1 says the frictional force acting on the box. Now, the marks that are allocated here is 4. So there should be 1 mark that any learner is supposed to get by choosing the correct formula. We have already seen that we need to apply Newton's second law of motion, and therefore the formula for Newton's second law of motion should be used. So the formula for Newton's second law of motion that will be awarded 1 mark would be F net is equals to ma. So every learner is supposed to be able to get that. Now, we look at the force diagram that is given there. The force diagram that is given there, we see that the applied force is acting at an angle. And therefore, if it is acting at an angle, we must first get the horizontal component of that force. The horizontal component of that force is Fx. So Fx is the one that causes this block to move horizontally. So when we substitute here, we might want to say Fx minus, because we see that the frictional force is going in the opposite direction. The frictional force is opposing motion. Fk is equals to ma. Now, we see that the 60 degrees is acting to the vertical. So we might want to use that, or one might also want to use 30 degrees. Remember, for vertical and horizontal, the angle should be 90 degrees. So 90 degrees minus 60 should give us 30 degrees. Therefore, we can substitute that as 150. That is the applied force that we were able to calculate, multiply by cos of 30, and that should give us the horizontal component, minus Fk, that is the frictional force that we're looking for. The mass that is given there is 60 multiplied by 0.02. Now, if we work with those numbers, we can calculate what the examiner is looking for. And then if we work with 150 cos 30, we get 129.90 minus Fk. And then we also need to multiply the 60 by 0.02. That is the acceleration that is given. Then here we're going to get 1.2. And now we need to transpose our Fk. We take it to the right. It's going to become positive. And then we take the 1.2 to the left, and then that is going to be negative when it goes to the other side, and that will be 90. If we minus them together, then we are able to see that our frictional force is 128.7 newtons. So our frictional force is 128.7 newtons. Now we are going to provide solutions that are written nicely. Let's go on to the next page so that we can go through the solutions. Now we look at the solution. The solutions are not written as we worked on them previously, but we do see that the frictional force is 128.70 newtons. Remember that the question paper will say all answers should be left into decimal places, and therefore we should not write our answer as 128.7, rather 128.70, 2 decimal places. And then we need to be able to calculate the normal force. When we calculate the normal force, remember our force is pushing our object downwards. So we had the weight, this force is the weight, the gravitational force, and then we had the normal force, and now we are going to have a third force vertically, and that is our Fy. Now all these vertical forces are balanced, and therefore we can write the formula for the normal force as normal force is equals to Fy plus the weight, because the two forces going down are equal to that force that is going up because they are balanced. Now our Fy is going to be 150 sine 30, 150 sine 30, and our weight will be 60 multiplied by 9.8. So when we do the multiplication there and addition, we are able to see that our normal force is 663 newtons. So that is how we go about with the applications of Newton's laws. Let's now go to vertical projectile motion. The key terms that are very, very important for you to remember in this topic are as follows: free fall and projectile. These two terms are very, very key to remember before you go on attempting this topic. And we should refer to all the definitions from the examination guideline. We will see that when we define free fall, we are talking about the motion, the motion of an object under the influence of gravitational force only. The word only is very important in this definition. The motion of an object under the influence of gravitational force only. But when you refer to a projectile, we are going to refer to an object that falls under the influence of gravitational force only. Please do not mix them up. Now, when we are dealing with this topic of vertical projectile motion, we should note that it is very important to know that all our objects are accelerating downwards. Their acceleration is 9.8 meters per second squared, and all of them are accelerating downwards. So it doesn't matter if the object is thrown upwards or is thrown downwards, all of them are accelerating downwards. Even if the object is going upwards, the same object, it is still accelerating downwards. It is very important to know that. Then air friction is ignored. We are talking about gravitational force being the only force that is acting on that particular object. The only force that is acting is gravitational force. Just remember that on the question paper, on the data sheet, this Fg is represented with the letter W. And this Fg is always acting downwards. So irrespective of whether the object is thrown upwards or downwards, all of them, they are experiencing a constant acceleration of 9,8 meters per second squared downwards, only when they are under free fall. The equations of motions are going to be used to do the calculations when it comes to vertical projectile motion. And these equations are only used because the acceleration is constant as 9,8 meters per second squared. We also need to read carefully when we come to this topic and all the other topics. We need to read carefully before attempting to answer the questions. We also need to be able to draw the trajectory of the object, the path that is followed by the object, which is called the trajectory. It's very important that we draw it if it is not given. Sometimes it is given, sometimes it's not given. If it is not given, it is very important that we draw the trajectory to indicate the path followed by the object. So we need to remember that position, displacement, velocity, and acceleration are vector quantities. The vector quantities, they have both magnitude and direction. Now, when dealing with these vertical projectile motion questions, it is very important to choose direction. You either choose upwards as positive or downwards as positive. And for all those equations, do not use your memory. Always refer to the data sheet. Refer to the data sheet at all times for all the equations, even if you know it very well. Always refer to the data sheet and copy the formulas or equations as they appear. Now, let's look at one particular question of vertical projectile motion and see how do we go about working with this topic. Let's read. A ball is dropped from the top of a building. This building is 20 meters high, and we are told that we ignore the effects of air resistance. In other words, we note that this ball that is being dropped will be under free fall. The word dropped in the statement is very, very important. In this case, it indicates that the initial velocity of the ball is 0 meters per second. So such words are very, very important. The word dropped indicates that the initial velocity of this ball is 0 meters per second. Let's look at the questions. 3.1 says define the term free fall. From the examination guideline, you're going to refer examination guideline 2021. You're going to see that the free fall should be defined as the motion of an object under the influence of gravitational force only. And then in 3.2.1, it says that we need to calculate the speed at which the ball hits the ground. Now, the trajectory of this ball now should be moving in this way. If we take this point to be A and the second point to be B, so this is the path that should be followed by the ball as it hits the ground, starting from A with an initial velocity of 0, then it will get to B with an unknown velocity or speed. And the question is looking for that particular speed. Now, if we look at this point A and point B, we can see that the displacement of the ball while moving from A to B is 20 meters. We can see that because we have drawn the trajectory. We can see the displacement or the distance between the 2 points to be 20 meters. And for us to start with our calculation, we need 3 pieces of information. So at this moment, we have only the initial velocity and the distance or the displacement. Let us choose direction so that we can tell whether our 20 meters should be positive or should be negative. If we choose downwards as positive, then this 20 meters should be substituted as a positive number. And the last piece of information that we have is the value of g, that is the gravitational acceleration, and which is going to be positive 9.8 meters per second squared, because we chose downwards as positive. So the velocity or speed which we do not know is the velocity at b or the speed at b. Now, how do we choose the correct formula? We want to choose a formula that has all these four variables. The formula must have initial velocity, the formula must have g, the formula must have our delta x or delta y, depending on what is given on the data sheet, and the formula should also have the vf. So if you can look in your data sheet, you will see that that formula should be vf squared is equals to vi squared plus 2 2a delta x. Remember, do not rely on your memory for all these formulas. We always refer to the data sheet. So the vf is what we are looking for. The initial velocity is 0. Remember, all the zeros are substituted as they are going to be awarded marks. And then the value of our a is 9.8. And then the delta x here is 20. So if we do the calculation here, that would be 9.8, 9.8 multiplied by 20 multiplied by 2. And then that would be 392. And then we take a square root of that. And then the answer that we're getting, remember, you should get the square root. So the answer that we're getting should be 19.79 meters per second. The question said speed. So because the question said speed, there is no need for us to indicate whether it's going upwards or it's going downwards. Then the next question says, we calculate the time it takes for the ball to reach the ground. So we now have the initial velocity and the final velocity, and we are looking for a formula that has delta t. So one formula that has delta t with all the information that we're having would be vf is equal to vi plus a delta t. Our vf is 19.79. Initial velocity is 0 plus 9.8 delta t. So we divide that by 9.8, and then we should be able to see that our delta t in this case will be 2.02 seconds. The last question, the velocity versus time graph. Velocity versus time graph. You should remember that our velocity versus time graph should be a straight line of the motion of the ball, no values required. So it will depend on which direction you chose as positive. So one possible velocity versus time graph, velocity in meters per second, and our time in seconds. So what is very important here is that the ball is dropped. So if the ball is dropped, the initial velocity is supposed to be 0. So we expect our graph to be starting from the origin. Now, as the ball goes down, we see that its velocity is increasing. So with an increasing velocity starting from 0, we can easily draw up a line that goes like that. And that will represent the velocity versus time graph that the examiner is expecting. Let's go now see the solutions that are typed out nicely. We have seen that the speed is 19.80. We have also seen that the time is 2.02, and then the graph as well. We have seen that this graph is supposed to start from 0. The labeling of the axis of the graph is also very, very important. So our free fall was defined as the motion of an object under the influence of gravitational force only. So let's carry on. momentum, linear momentum, and impulse. So for linear momentum and impulse, the following definitions and concepts are very important. We need to be able to define momentum and also associate the formula that is related to momentum from the data sheet. We also need to be able to state Newton's second law. We have said that earlier, and also associate the formula related to that. We must always copy the formula as they are from the data sheet. And then we also have impulse. We should be able to define impulse, and we also need to be able to express this impulse as the product of the net force and the time, and that should be the impulse. And then isolated system, we must be able to define that from the examination guideline. Now, the principle of conservation of linear momentum from the examination guideline, we must be able to state that the total linear momentum of an isolated system is conserved. And this is very important, elastic and inelastic collisions. We need to be able to remember that for elastic collisions, both momentum and kinetic energy are conserved. For elastic collisions, both momentum and kinetic energy are conserved. And for inelastic collisions, momentum is conserved, but the kinetic energy is not conserved. Very important. Now, for linear momentum, we need to look at questions that involves collisions, and we also need to look at questions which involve explosions as you prepare. And while you are dealing with these collisions, you must be able to calculate the change in momentum. Direction is very important as you calculate your change in momentum. We need to know that Newton's third law is applied as the objects are colliding. The force exerted by one object on another must be equal to the force that if object A exerts the force on object B, the force that object B exerts on A must be equal and in the opposite direction. This law is very much applicable in momentum, and this average force exerted by each object depends on the contact time. So that is the formula that we referred to earlier. It depends on the contact time. If the contact time increases, we expect the force to decrease. And if contact time decreases, we expect the force to increase. And then we also need to remember that the Newton's law, according to Newton's law, the net force causes this object to change in momentum. Very important. The reading of the scenario carefully and underlining the keywords is very important. It is also very important to note that these quantities, velocity, momentum, change in momentum, average force, they are all vector quantities. And if they are vector quantities, you might want to indicate direction. They have both magnitude and direction. So when you are dealing with momentum problems, it is very important to take direction into account. Direction is taken into account at all times. Choose the direction which you want to be positive. Refer to the data sheet all the time when carrying out any calculations, and pay attention to the mark allocation. For elasticity of collisions, you can prove whether the total kinetic energy before is equal to the total kinetic energy after. But very important, do not start off your calculation by saying the total kinetic energy before is equal to the total kinetic energy after. Rather, calculate the total kinetic energy before and calculate the total kinetic energy after, and then compare. If they are equal, then the collision is elastic. and if they are not equal, the collision is inelastic. Now let's look at the multiple choice relating to momentum. Which of the following physical quantities is equal to the product of the net force and change in time? So we are looking for a physical quantity that is equal to the product of net force and change in time. If you know your definitions, you'll automatically tell that. If you are still not sure, you can rely on the formulas. The power, you see that the formula for power is given as W over delta T. The formula for work will be the force multiplied by displacement. The energy will also be calculated from the same formula. And then for impulse, we'll have F net multiplied by delta T. So the question says, which of the following physical quantities is equal to the product of net force and change in time? Then it is very easy to see that the best option here will be B. So the best option for this question is B. Let's move quickly into the next question. The cricketer hits an approaching ball back in the opposite direction. We are told that the ball is being hit in the opposite direction to its original direction. Which one of the following statements regarding this collision between the bat and the ball is true? Let us see the first option. The collision is perfectly elastic. Now, for us to know if a collision is perfectly elastic, we need to know if the kinetic energy is conserved. And when we look at the information here that is given, there is no way where we are told that the collision is, the kinetic energy is conserved. Therefore, we cannot take this option. Let's go to B. The momentum of the ball stays the same before and after collision. So we also don't know the initial and final velocities of the ball. Therefore, we cannot tell whether the momentum of the ball stays the same before and after collision. What we know is that the total momentum before collision is equal to the total momentum after collision. We know that there are two objects that are involved here, that is the ball and the bat. But the statement is only talking about the momentum of the ball. Therefore, we cannot conclude about that. Then C says the magnitude of the net force of the ball on the bat is equal to the magnitude of the net force of the bat on the ball. So this should remind us of something. We should be reminded of Newton's third law. So Newton's third law is applicable to this, and therefore we can accept this. However, we still need to check D. D says the magnitude of the net force on the bat on the ball is greater than the magnitude of the net force of the ball on the bat. So we cannot accept this option since it violates Newton's third law of motion. And therefore, our best answer is supposed to be C. We carry on. Now we are going to go into a short question on the linear momentum and impulse. And learners, you're going to be given some time to work on this question, and then we are going to discuss it after. We are going to give you 3 minutes for you to work on this question, and then we are going to discuss it after. Welcome back, learners. I hope that you were able to work through the questions for 10 marks. Let us go through the question and therefore discuss the solutions. We are told that ball P of mass, the mass is given as 0.16 kg. It's moving east with a speed of 10 meters per second. We see that here. It collides head-on with another ball Q of mass 0.2 moving west at the speed of 15. Now, we're already seeing that there is east and west. So one has to be positive and one has to be negative. It will all depend on which direction do you choose to be positive. After collision, ball P is moving west at the speed of 5 meters per second, as shown in the diagram below. Ignore the effects of friction and the rotational effects of the ball. The questions are as follows. Define the time momentum inwards. Calculate the velocity of ball Q after collision and the magnitude of the impulse of the ball during the collision. So let's go through the solution. The momentum is defined as the product of the object's mass and the velocity. And then we go through 4.2.1. In this question here, one of the formulas will receive a mark. The first formula can be the sum of momentum before is equal to the sum of momentum after. The other one can be MP, mass of P, and then the initial velocity of P plus mass of Q multiplied by initial velocity of Q is equals to mass of P and the final velocity of P plus mass of Q multiplied by the final velocity of Q. Let's pay attention to the substitution. The underlined substitution here will receive 1 mark, bearing in mind that the 10 and the 15 must have different or opposite signs. They must have opposite signs since they are going in opposite directions. And the 15 and the 5 must have the same sign since they are going in the same direction. And then we're expecting an answer of 3 meters per second west. So be mindful that west has a mark on its own. Then 4.2.2, we are calculating the impulse. So we should remember that impulse is equal to change in momentum. And then we are focusing on ball P. And therefore, the velocity substituted here, those are velocities of P. Remember that the second velocity is in the opposite direction. Hence, you see the -5, -10. And then our impulse here is 2.4 Newton second. We need to remember that we chose how we chose direction, and therefore this is also supposed to be west. So that was the impulse, and that is basically what you need to go and revise when it comes to impulse. Work, energy, and power. The following definitions and concepts are very important when dealing with work, energy, and power. So we need to be able to define the work done by a force and be able to identify the formula associated with that on the data sheet. We will see that the formula is F delta X cos theta. And then we must be able to understand what is the meaning of positive work and negative work. Positive work being the work that is transferred into the system, and the negative work being the amount of work that is being taken out of the system. The principle of conservation of the principle of conservation of energy is very important to revise. And the work energy theorem, you must be able to state the work energy theorem and be able to identify the formula and also be able to use the formula. There will be 1 mark that is awarded for you to copy the formula as it appears on the data sheet, and also to be able to use the formula. Now, All of you learners, you must be able to define a conservative force, and you also need to be able to define your non-conservative force. All these definitions are there on the examination guideline 2021. You also need to be able to define the word power. Now let's move quickly as we are running short of time. The work energy theorem formula will be given on the data sheet. That is, the W net is equals to delta EK. So this net work done can also be calculated with the formula if the net force is given. So it's also very important that to know that the net work W net is equals to the total work, which is given here as the sum of the work done by all the forces present. It is also very important to know that when dealing with this topic, the free body diagram is very, very important. No calculation can be done without the free body diagram, as we did in Newton's laws of motion. So the W net here is equal to the change in kinetic energy, the change in kinetic energy being the final kinetic energy minus the initial kinetic energy. It is also important to know that there are other formulas as well. Work done by non-conservative forces being equal to the change in potential energy plus the change in kinetic energy. Remember to copy these formulas as they appear on the data sheet. Now, we have talked about the principle of conservation of energy, and then mechanical energy from grade 10. The work energy theorem, very important. And the work done by non-conservative forces is the change in mechanical energy. By mechanical energy, we are talking about the change in EP plus the change in EK as indicated earlier. Let's now go through the work energy theorem principles quickly, and so that we do not get short of time. So we are dealing with work here, and the formula for calculating work is W is equals to F delta X cos theta. The positive work will only be attained if the force and the displacement are moving in the same direction. And if the force and displacement are moving in the same direction, cos of 0 will be substituted when calculating the work done. Now, once the positive work is calculated, all the work done by the forces can be added to get the positive net work done. And we need to know that the positive net work done increases the kinetic energy of the system. When coming to negative work will be obtained if the force and the displacement are in opposite direction. And to get that, the cos of 180 should be substituted. And then we'll get the net work done if all the work done by the forces are added. Now, we need to know that negative work decreases the kinetic energy of the system. Now, zero work will only be obtained if the force and the displacement are perpendicular to each other. And for that, the angle of 90 degrees will be substituted. And then all the work done by all the forces, they must be added into the net work done. And that net work done, we know from the work energy theorem that it is equal to the change in the object's kinetic energy. Now, if we go quickly into work energy and power question, we can look at this question that says that a windmill on a farm is used to pump stationary water. So because we are told that the water is stationary, we now know that the velocity of the water is 0 meters per second. And then this water is at point A. And then in a well, the water flows past point B. So this water will go all the way to point B. and point B is 35 meters above point A. And when it gets to point B, so the speed here is 0 meters per second. And then we are told that the speed here will be 2,1 meters per second. So the questions are as follows. Calculate how much energy is needed to pump the 90 kg of water out of the well to point B. So we see here that there's a change in kinetic energy and there's also a change in potential energy. Therefore, the formula W and C might be very helpful in dealing with this question. However, it is not the only formula that can work out this solution. So let's go quickly into the solution as we are running short of time. We are going to use the formula as indicated. The change, the way the delta symbol delta means change, which means final minus initial. So here we're going to have the final kinetic energy minus the initial kinetic energy, the final potential energy minus the initial potential energy. The final velocity there was indicated to be 2,1, which is going to be squared. The 0 here indicates that the initial velocity was 0. And then also the final height was 35. That should give us the final potential energy. The 0 here means that the initial height was 0. And then we are able to calculate the energy as 31068,45 joules. Now, once the energy is calculated, it's going to be very easy for us to calculate the power because we're going to divide by the time that is given in seconds. And then we are able to tell that the power of this motor is 517,81 watts. Let's move quickly. We have talked about that. And now we go to electrostatics for the last few minutes, 10 minutes that is left. We have two identical neutral. We have spheres that are neutral here, and they are identical. They are placed on insulated stands. You need to know that these insulated stands, they are there to make sure that the charge is not leaking. Now, they are brought into contact and a charged rod is brought near M. So there's a charged rod here that is brought near M. When the spheres are separated, it is found that this number of electrons were transferred from sphere M to N. So we have electrons that are being transferred from, these are electrons that are transferred from M to N. Now, the first question says, what is the net charge on sphere N after separation? Remember that sphere N has received some electrons, so we expect it to be negative, but they're not looking for that. And then we expect M to be positive since it lost some electrons. And then the charged spheres M and M are now arranged along. They are now arranged in this way in space such that the distance between the centers is 15. And then point P lies 10 centimeters to the right of N, as shown in the diagram. The questions are as follows. 8.3, define the electric field at a point. And then 8.4 says, calculate the net electric field at point P due to M and N. So let's go to the solutions quickly. We need to remember that this one here, it emanates from the principle of charge quantization, and therefore the formula associated with that from the data sheet will be N is equals to Q over E. We are going to substitute the electrons here, and then the E, we know that it's supposed to be 1,6 times 10 to the power negative 19 coulombs as given on the data sheet. Then we are able to get Q. Now we need to know that the charge of N should be equal to the charge of M, since the electrons that are gained in N, they are coming from M, but they are having opposite charges, since the other one gained electrons and the other one lost electrons. Let's go through the solutions. Now, the formula as indicated is being used. the number of electrons here substituted, the charge of one electron is substituted, and we are able to get the charge on that sphere. And then 8.2, we see that the charge on N is the same as the charge on M, but the other one has excess electrons and the other one has a deficiency of electrons. Therefore, this one is negative and the other one is positive. Now, 8.3 says define electric field at the point. Electric field at the point is defined as the force experienced per unit positive charge placed at that point. And this underlining indicates that all the weights that are there, they should be there for a mark to be awarded. The last question says calculate the net electric field at point P due to the two charges. We use the formula for calculating electric field as E is equal to KQ over R squared. The value of K is given on the data sheet. The value of the charge is given there. The distance of 0.25 is the distance between the charge and the point. And then we also have the other charge that is only 0.1 meters away. Now, the direction is told in this way. How do we tell direction? We consider the point P to be positive, and we have learned that this one is negative, and we have also learned that that one is positive. Therefore, electric field at P due to N is supposed to be electric field at P due to N is supposed to be going to the left, and electric field at P due to M is supposed to be going to the right. How do we know that? The positive and the negative, they attract. We are looking at the direction of P. So P goes towards N because they are attracting each other. And P goes away from M because they are repelling each other. So with those directions, we see the one is going to the right and the other one is going to the left. And because they're going in opposite directions, to get the net electric field now, we have to subtract them. We subtract their electric field, and then with the direction that is chosen, we are able to see that the answer is 0.60 Newton per Coulomb. So that is our working on electrostatics. Now, electric circuits. We are left with 5 minutes to look at electric circuits. However, we need to look at the EMF as one of the concepts that are very key. You need to be able to define EMF. You need to be able to define the terminal potential difference. Very important is the definition of internal resistance as the resistance within the battery that causes a drop in potential difference when the current passes through it. It is very important for you to be able to define this internal resistance as per examination guideline 2021. The Ohm's law, you must be able to define that. And then you must be able to calculate resistors in series and resistors in parallel. The power as the rate at which work is done should also be defined as per examination guideline 2021. Now, we are left with only 4 minutes. So I will ask you to screenshot the summary of electricity. If we can screenshot this page, then we screenshot this next page of the summary, and then you will have the activity as the homework. If we can screenshot this slide, and then we also screenshot the last slide as the homework, and then this will be the solutions of the homework. The first slide, if we can screenshot this one, since we are running in short of time. And then the last one, the second last, if you can screenshot this one as well. And then you screenshot the last one. So that this can be the homework that you can work on. But before we close, I'd like to go back and look at the graph. The graph is very, very, very important. Now, on the graph, when you are working on the graph, it is very, very important to look at the scaling of the graph. The scaling of the graph is very, very important. You need to see that here there are 10 boxes. There are 10 boxes. These 10 boxes, they make 0,2. So for you to work with this graph, you need to divide 0,2 by 10. Then you will know each unit of the box. The same with this one, 10 boxes, they make 2. For you to know the unit of each box, you divide 2 by 10 so that you will know the correct measurement of the graph. The other thing on the graph is that the gradient on the graph here, the change in y will be the change in v, the change in x will be the change in I, and this will indicate that the gradient of the graph will give us the what? The resistance. The graph with the higher gradient will indicate a higher resistance, and the graph with the lower gradient will indicate a lower resistance. So this resistance here is higher, and this resistance here is lower. So we can tell that by looking at the gradient of the graph. Learners, thank you very much for joining our lesson. We hope that it helps you a lot into passing your exam and making sure that you score the marks as much as possible. We wish you very good luck in your examination, and we really hope that you are going to make it as per your wish. Thank you very much.